and it should be adequately providing you the moisture barrier against the external environment. Because if you see that your area in Indonesia and in Malaysia, so we usually have high humidity around 60 plus 80 sometimes based on the rainfall. So we have high moisture, so we want a barrier from the external environment to protect our food. Then at the same time, we want to protect the shape of the product. We don't want that our all, for example, chocolates, candies, chips, potato chips, all snacks are crushed. So we don't want our final product to be crushed, but it should be having its own shape until that point it goes to the consumer. So these are the few criteria, attributes that you can say for an ideal packaging. So, but compared to other kind of packaging that we have special challenge in terms of snacks and confectionery, because these sometimes products are not or ordinary products. You might have seen that some chocolates are so premium that you cannot get in ordinary rupees in ringgit. You need to spend some kind of some significant amount of money to buy premium chocolates. Okay, so I don't want to brand any industry here, so that's why I might not be able to give example. And all these pictures I'm putting here in this slide is not for branding purpose. I'm not agent of any company. I'm just using that images just for the sake of teaching purpose. So I mean that we have unique challenges for confectionery and snacks because most of the products are fragile. Like for example, chocolates can melt, chips can the potato chips, for example, Lay's, it can break easily. So we have special issues of fragility. Our items are quite delicate. So we have to check our challenges and then we have to decide our packaging. Then perishability, exposure to humidity, temperature, and oxygen. So if a product is perishable or its product is stable, so based on processing and based on the external environment, we are facing special challenge of perishability. Because if we have what you can say high humidity, the possibility that your potato chips may be rancid easily. And I know that rancidity, you might have heard the term rancidity means giving off flavor because of your fats and oil that you're using for frying. It turns off. It means it gives off flavor, a bitter taste. So this is a basic food chemistry. I hope you know about acidity. Sensory appeal, the aroma should be nice, texture should be maintained, and visual presentation at the same time. So you can see that we don't want the chocolate is crunched already, okay, crushed already. Similarly, if you go to the picture number 2 below here, you can see that we want some sensory appeal. The package is nice, aroma, and then visual presentation. You want to see that, okay, you see there are some windows in the package. So you want to see that visual presentation is there and nice to convince our consumer to buy our product. Then the portion control. Sometimes you just only give single bar or you give single serving, as for example, 50 gram, 25 gram, but it could be a family pack. Like you have, like in a secondary pack, you have multiple chocolate bars, so it could be family pack. So based on your objective, so you can define portion control. Consumer expectation that in our childhood we really like fun colorful items. So for us, okay, for the producer who are producing the confectionery or snacks for children, they will be looking on fun and colors. And we all remember that we have been taken multiple kind of colorful lollipops and candies in our childhood time. And if we are looking for a little bit of maturity, then we say that okay, it should be eco-friendly, it should be resellable, and it should be having some other attributes. So based on the consumer expectation, you have to match the consumer expectation while you are packaging your snacks. So let's move to the emerging trends little bit to basically going to the topic of candy packaging, confectionery packaging. Emerging trend, you are already very well familiar about that. Everything is getting smarter. QR code is everywhere. Okay, no traditional way of tracing any of your product in the market. So now by the QR codes, you can see that if your product is still okay or not okay. Then minimalist design, because we have a lot of issues with plastic pollution to the environment, because you know very well that we are getting this plastic from petroleum byproducts. So then that is creating environmental issue by piling up into the sea, and our ocean ecosystem is getting disturbed. The fish and many other aquatic animals are not clean and pure anymore. So that's why we want minimalist design, having clean labels, and finishing is nice. Minimum ingredients should be used. So we want that. Okay, minimalist design is also introduced in this way. Then personalization, because of the diversity of the country and I mean the fashion and trends. So we have some kind of product like that is a limited edition for that particular. For example, Eid al Fitri. For example, for this Christmas we have only personalized items, limited editions that available only in certain countries in certain grocery stores. You might not be able to get throughout the world, but it is your personalized limited edition. And then some regional flavors. For example, few things you can find only in Indonesia. That's why dodol and pandan based many flavorful confectionery that you can only find in your own country, but you may not find in overseas. That's why you will be very happy when you're going overseas and you find your traditional item over there. But we are talking about personalization, so keep that example that few items are available only in Indonesia. That's why you like that product since your childhood, and that is only your regional flavor. No any other country afford that kind of flavor, for example. So their buds for taste are different than yours. So that's why you like maybe durian or dodol, but not many people maybe like durian. So
This meeting is being
you will
recorded.
scan and you see your product. Then how many compartment in a package you want to have, dual, triple, whatever. So depend upon your choice. And then it might not be a suitable example here though, but you see that built-in spoon is there to eat vanilla ice cream. Okay, from that brand. So I don't want to announce the name of any company in particular. So you can see, and then what kind of finish, for example, matte finish or gloss finish. Usually, the finishing of the product also identify is the speciality. Some premium products just come in matte finish, or some premium products of some manufacturer will be in the glossy packaging. So these are the some emerging trends. Now the real topic starts about sugar based confectionery products. So as we had defined in the first slide that what are the confectionaries. So we have defined there are candies, there are chocolates. Okay, so here we're coming to a topic that what sugar based confectionery. So hard candies, you might have seen lollipops, mints. On the right side, you can see the example too, to clarify what I'm talking about. Soft candies, some gummies, marshmallows, like you can see here. It's not
This meeting is
and
being
oxygen
recorded.
barrier. So mean that if we want to have strong barrier properties, we don't want that to pack it into paper. Of course, we want to have a package that provide us good barrier properties. Okay, later we will decide on what kind of material that keep provide you the better barrier properties and why not others. So I can give you example. For example, you can pack in a laminate. Laminate is a kind of aluminium, paper plus any other plastic composite. Okay, so we can have a laminate. So that give us stronger barrier property against the external moisture and oxygen. So we don't penetrate into the food. In terms of soft candy, the requirement was this. How about the chewing gum? It demands flavor retention. If it is a mint flavor or any other kind of lemon flavor or many multiple flavors, so you want to hold your flavor until it reach to its end of shelf life. And it uses multi-layered packaging for freshness and portability. Okay, multi-layer is a kind of laminate as I talked just now. Okay, so let's see. Next category is a table providing us the feature, and based on three categories of the candy that we have just seen in the previous slide, what is their product sensitivity and what the packaging formats usually we have and what the packaging material. Format means usually the available portion in a single serving are in the form of wraps, in the form of pouches. But the packaging material that we have, like finally, what kind of packaging material suits to each of the category of the sugar-based confectionery. So, as we just seen in the previous slide, that the sensitivity to the moisture and aroma loss is the problem. So it can become sticky if it exposed to external moisture. So for that, we want what kind of package formats available. Flow wraps, pouches, tins, small cartons, for example. And then what kind of material could be suitable for that? Polypropylene, cellophane, foil laminates, paperboard is the secondary packaging in this case. Laminates, I just explained a little bit in the previous slide as well that we have more than one packaging material laminated on each other to give better barrier properties. Cellophane, propylene is a kind of plastics that we have in normal daily life. Transparent plastic could be like polypropylene, polyethylene, but here is a polypropylene. Soft candy are also just suggested that we prone to melting, so we want flow wrap, so this kind of packaging stuff formats availability is there, and then basically we're talking about focusing on this polyethylene terephthalate or polypropylene laminates. And metallized films means any film that is having some kind of metal, I mean aluminum or tin layer inside. So papers, board sleeves, like sometimes you have soft candy in just an open, only it is sealed from the three end but it's not from the top, so you have paperboard sleeves like in a popcorn shop you will get your popcorn in a paperboard sleeve sometime. So for the chewing gum, again, the sensitivity, we want to retain flavor, different kind of packaging comes into the market, and then we have foil laminates, and it could be PET, it could be PVC, polyvinyl chlorine, polyethylene, polypropylene. So again, these are the few packaging material and few packaging format about sugar confectionaries. So again, I'm explaining it separately a little bit more that for the hard candy, you want twist wraps. Twist wrap means you have a candy and you just wrap it like that. Okay. Flow wraps means in your machine horizontally you are keep wrapping through the machine. So it is flow wrap. That's why we call flow wrap. Okay. While it is flowing on the stage of the packaging machine, it's getting wrapped. Okay. And at the same time, it is been sealed from the two ends. So you can imagine like we have a tube of plastic and then we are putting our product and while it is moving, it gets sealed. So it's called flow wrap. And pouch is similar but a little big in terms of resealability. So we can have multiple packs inside. So flow wraps is usually for the primary packaging for one candy, for one chocolate bar. Pouches, it could be multiple items in one bag, and then some tin and boxes that depends upon what kind of material you choose. Then the material here is PP, cellophane or the wax paper, any laminates. Again, for the soft candy, flow wraps, as I mentioned in the previous slide, flow wraps. Then stand-up pouches. It could be standing. And then blister packs. Blister pack, if you can see, blister means a kind of, if you have seen any medicine coming in a transparent, or if you have seen what you call some lozenges for cough, for example, strepsils, for example, just giving you an example. So it is held in the six pack of six in a one plastic. All that plastic is there at the back, and then blisters. So you can see six items or four items, four candies. So that is called the transparent. We call blister pack. Okay, you can see typically it is designed for medical style soft candies or lozenges. Then plastic tubs or trays, it for be for premium products. Okay, some kind of marshmallows and soft mints. Material, as we have defined already, the PET, PP, metallized film, paperboard sleeves. Again, for chewing gums, again blister packs are available, and then stick packs also available. Like you can have multiple sticks, the longer sticks inside of your pack. So you can have five sticks, for example. Then pouches and bag and tubes and canisters like that. And then material foil laminates because of its based on its property. We want to hold certain quality of our product. So that's why we are choosing different materials. When it comes to chocolate, because also a kind of confectionery. So in this case, we can see the second category I'm discussing here is the chocolate. Chocolate bars, very usual. You are very familiar. You are taking Snickers, you are taking Mars, you have many other brands available. Filled chocolate means some truffles or pralines. The inner is filled with soft molten material. It could be your chocolate, or it could be any other cream filling. Then coated snacks. Okay, like sometimes you have coated peanuts or coated almonds. So that comes confectionery, chocolate confectionery. So the chocolate is coated on it. That's why some brands are selling this chocolate snacks mixed with nuts. Okay, so the packaging need, of course, it is temperature sensitivity because it melts on room temperature sometime. Or if you hold the chocolate in your palm for a certain period of time, it start melting. So based on the grade of the chocolate or based on the cocoa, I mean, cocoa butter or cocoa powder they are using. So the quality, the premium chocolate, sometimes the dark chocolate, for example, it melts earlier compared to any other chocolate, white chocolate or ordinary blends. So it's based on the temperature sensitivity, and that goes to the composition that how much cocoa butter have been used. Okay, beside other additives. I hope you know about cocoa butter, you know about other additives, for example, that are used, and some hydrogenated fats, you know very well about that. So, based on the composition, I mean, you can check temperature sensitivity of your final product. Light and oxygen barrier, because wherever the fats is there, wherever the moisture is there, wherever the sugar material is there, hygroscopiness is there, rancidity is there, off flavor is there, and moreover, you might have heard about blooming of the chocolate. Like after putting it in a chiller and then you melt it, then you again freeze it. So your chocolate surface will be not originally black. It will turn to kind of brownish, little bit of shiny, yeah, glossy appearance on your chocolate bar itself. If you do multiple, at least not multiple, maybe two cycle of freeze and thaw. So that is called blooming. So that is another issue that comes with the chocolate. Then premium feel for gifting. Sometimes you want a premium feel that I mentioned earlier that for the premium we sometimes go for matte, MATTE. kind of packaging. We want to distinguish it from ordinary packaging, and we say that this is a premium product and could be given as a gift on our celebrations or on our feasts. So here are some examples. You can see chocolate bars. Then you can see chocolate pralines, chocolate filled with a soft center. So you see that in there you have a soft center fill inside. Okay, so once you have it's a melt in the mouth kind of things, you feel like something is oozing in from the center to your mouth. Then chocolate truffles, a similar category, but it was coming from French origin. So again here, if we have chocolate, then what kind of formats that is available? Some we have seen in the previous slide as well. And what kind of packaging material are suitable? Okay. So based on the product sensitivity, it is sensitive to heat. Okay. What kind of packaging format you afford or you should choose? And then what the packaging material that can support this, they can provide you heat resistance, for example laminated foil, metallized film. Okay, for the sensitivity of the light, you don't want any product to be transparent. Means you package, if the package is transparent, the lights will be there, and then it will definitely interact with your food, and it will cause your chocolate or cocoa butter that is inside to get rancid before its shelf life ends. So we don't want our food or chocolate to be spoiled well before our shelf life. So for that we want non-transparent packaging. So laminates or foils, metallite, polypropylene can be a good choice in that case. Again, sensitivity to the odor and the flavor loss. We don't want that our bag lose its originality. So for that, we are suggesting to select multi-layer films or aluminum foils. Then sensitivity to oxidation, because heat, light, oxidation, humidity, so all that. So we can choose even different kind of packaging that we will be discussing in our later slide about vacuum and modified atmosphere packaging as well. And what kind of material that support that kind of packaging. Okay, so it will be PET, foil laminates, ethyl vinyl hydrox, sensitivity to deformation. So we want some kind of rigid box. We don't want our gift pack on any Christmas Eve or Eid al-Fitr Eve that it is spoiled before we given it to our hosts or to any our friends. So we want to keep that product intact, that chocolate intact. So we are selecting for that what kind of packaging material, paper board. Then again, the some kind of blisters. Then for the premium presentation, like again, it comes to the gift packs. So you want some product to be seen through the window, and you send this is some wraps should be embossed. I mean, some wraps are very nice that you can see that the labels is you can feel. Okay, very nice feeling. You can touch and you say, oh, the text you can feel. Like even with closed eyes. So embossed wraps. Okay, so in this case, we have different kind of packaging material suggested for chocolate. So the third category comes here, the snacks category. As we defined in the first slide, snacks, confectionery, and then we come to chocolate. So this is snacks category. Snacks could be of what category? Sorry. Snacks could be potato chips because if they are savory snacks. Crackers are a little bit thicker than the chips. Okay, like you can see here in the slide. So some are crackers, like this is chips. So the chips is usually thin. Okay, it might not be differing much in terms of its composition, but more or less its geometry and the style of presentation and the final shape of the product is defining it. It's the chips cracker, but sometimes they interchangeably use that terms. Popcorn, you're very well familiar. In the middle are the puffed maize grains, sometimes coated with chocolate, sometimes coated with caramel. So this is the morning time. I hope that some of the students may not be feeling, maybe feeling that want to eat right now. So it is coated with a different kind of uh, material. Okay, sometimes we have just flavors only. Sweet snacks, cookies. And some cereal bars, we claim that this is very healthy cereal bars, multi-grain cereal bars, granola, and many other items. And sweet snack also comes some dried fruits or raisins, but again blended with chocolate or blended with some other kind of sugary stuff or some flavorants added. So this is the cookies example here. Healthy snacks, of course, nuts are the most healthier product consumed because of their high omega fatty acids, okay, omega-3 fatty acids, and the functionality they perform in the body. So some seeds, of course, seed are rich source of proteins, and some protein bars. So here one of the brand, I don't know, Nature Valley. I just take a random example here. So these they are claiming that they have healthy protein bars. Then packaging needs for the above mentioned snack category. Again, we want it resealable. For example, we don't want to finish. If you see here, it's a resealable kind of packaging for marshmallow and for other things. So we want that maybe we are sitting and we are studying, we are doing our homework, for example, watching some contents, for example, and we want it, okay, maybe we consume some and then we leave it again. And then we come and we eat again. But sometimes some potato chips, for example, Lay's or any other brand available in your country, once you open, you may not be able to close it. So we want resealability for multiple servings. And we want to maintain the crispness of the product. So that is the basic need of these snacks. And branding, of course, you can see that different pack can give a branding here that what is the name, what is the composition, how many bars inside. So your product brand may have special requirement that you go for and you choose for based on your product. So packaging requirement for this category, because we have discussed the category like candies, chocolates, now coming to snacks. So for each we have discussed about the packaging requirement. Again, the issue comes with that all the external factor that you have, that any food is affected similarly, any snack, chocolate, candies might have similar kind of external factors that affect. So the first factor comes moisture sensitivity. So we want any of our crackers or the chips that we categorize under the snack, the package should be moisture barrier. Then, of course, we don't want our chips, potato chips, to be crushed, so we want a cushioning effect or some kind of rigid format. But you might have a question that why our Lay's pack from PepsiCo is still in a soft form, in a pillow form, and what makes it a cushioning effect. Like you see that your chips may be very less, 50 gram, for example, in a pack of like 200 ml. So the volume of your chips is there, but a weight of your chips is very less. So what gives the cushioning effect? The gases that we use to fill that packs, and usually we use inert gases, nitrogen, sometimes blend of nitrogen with carbon dioxide, depend upon our product inside. So that provides a cushioning effect. Otherwise, we can choose rigid formats. Okay, maybe we look into Pringles and any other brand that have hard tube or container that your chips are stacking inside. Okay, so to avoid its breakage, and we have this kind of formats. Then aroma and flavor retention, we go for fried snacks and nuts that we have. So we want that multi-layer films or foil or laminates that can protect that aroma or the flavor for a longer period of time as per our shelf life determination. Again, portion control, you want to make it single serving or multiple serving. So you choose based on that. And shelf life, of course, as I mentioned, that usually your snacks have shelf life of how many months. It is very, very perishable snack. So you can choose any kind of packing based on your final product, for example. So packaging materials, in this case, now we are turning to the packaging material itself. Previously, we defined any category and we go for its packaging requirement and the packaging formats. Then we have touched some of the packaging material though, but here I am bringing in a little bit more detail about packaging materials that generally we have for packaging of confectionery and snacks. So there are mainly three categories probably. So first is the plastic. In this plastic, we have polyethylene. So, what gives the property of polyethylene to be selected for our confectionery packaging is that it is providing us flexible pouches. It can give us flexible packs. Then it is a moisture resistant. And here is an example that it could be used for chips packs. You might have seen that polyethylene have been used traditionally, like if they are used selling kind of cassava snacks, banana chips. So they are using transparent polyethylene bags in your night market places or at your town, probably. And then polypropylene, it's a better heat resistant, it's good for sealing and used for candy wrapping. Okay, switch wrap or turner wrap. Then polyethylene tetraphthalate, high clarity, better strength. So that's why we use it for making bottles, trays, tubes, tubs, whatever. So the advantage of having plastic compared to other packaging material, of, for example, paper. So why we are having plastics and what's the benefit plastic provide compared to other packaging material? It's lightweight, it's cost effective, it's printable. Challenge, of course, as I mentioned in some of my previous slides that I mentioned that environmental impact of plastic is so bad that we have got global warming issues and climate change. So many things are there, and aquatic ecosystem is disturbed by the plastic. But of course, there is a recycling capability existing. But again, you cannot totally or 100% recycle all the plastic that's going to pack your food. So that's why when we think of environmental impact, so plastic have a big challenge. So here are certain materials like you can choose out of the three plastics based on your feature and property you're looking and what kind of confectionery types they can hold. Okay, and you can see the thermal stability, heat resistance, and then barrier property. What can provide you the ideal barrier property? Okay, so based on your choice of your product, and you can choose among the three plastic I have given as an example here. Okay, for example, marshmallows could be suitable with polyethylene, then hard candy, maybe polypropylene. For chocolates and premium kind of products, maybe you can go for PET material. Again, a little bit more explanation that PE is ideal for marshmallow, PP is for hard candy, caramel, truffle, toffee, and then PET is good for premium gummies and chocolate box. So this is the second packaging material. After the plastic, now we come to the paper as a packaging material. Used in wrappers, outer cartons, and trays. You can see that most towards secondary packaging are rarely used as a primary packaging for your chewing gums or some kind of things. But more or less, it is usually used for secondary kind of packaging. You can see it's in terms of boxes. Chocolate box here on your right, then snack sleeves you can see on your right. So these are usually secondary, in this case is a primary packaging, but in this case is a secondary packaging. So advantage because as I mentioned in previous slide, plastic is not biodegradable. Okay, though we have some advanced research where they're saying that some bacteria can degrade plastic, of course, but not all kind of plastic and not all kind of bacteria can do that job. So the benefit we're having as a paper as a packaging material is biodegradable and excellent printability means once we have our product we are going to brand our name on the product itself, like for example here you can see Olmec. So the name the paper have excellent printability, sorry, and it's lightweight as well based on the thickness of the material you can choose, so it could be lightweight as well. Limitation, of course, paper is not resistant to moisture and the external humidity, and sometimes it's not grease resistance. Like for example, imagine you are buying ayam goreng, I mean fried chicken, and what will the suitable example? Even you open the potato chips box and you put in on a paper while you are studying, while you are working. So you put on your notes and you find that your notes get soggy and your notes have your book pages got oily. Why? Because this paper is not grease resistant or not oil resistant, and it is not moisture resistant, of course. So oftenly laminated with plastic or foil to improve its barrier properties. Okay, so in this case, we have to blend it with, as I mentioned, in laminates or in different foils, we compose it to different layers. I will show you in next slide somewhere to talk about when we are talking about laminates. Okay. So the chocolate box is an example, and sneak sleeves is another example. Here you can see when we're using paper kind of packaging material. Here again, that what the paper packaging can provide us in different categories of the packaging material here based on paper and what kind of confectionery application it have for us. Okay. So next we're going to, these are some of the example from the previous slide, the paper board. Okay, so this is paper board, this is craft paper, laminated paper, and some other categories you can check. Then next category comes after the packaging of the plastic material. Second was our paper, and third is a blend. Some foils, it might be metallic or metallized, and laminates as well. So like aluminum foil, we know very well that most of the packaging that we sometimes easily found is this kind of packaging because these are not from certain manufacturer, but our traditional selling. Sometimes they use this kind of packaging in our local grocery stores in our local towns. Aluminum foil excellent barrier to light and moisture. Could be used for different functionality. You can see here. So here is one of the example of laminate. Like first layer, number C, 1, 2, 3, until 6. It could be less or more depending upon the product that you are going to pack into it. But generally, this is one of the example that you have polyethylene, then you have paper layers, third layer polyethylene again, then aluminum. Aluminum comes as metallized as well. So polyethylene, then polyethylene. So based on their functionality, what they can provide, some provide adhesion, some provide barrier, okay, some provide printability. So you can choose the laminate that you want to define. Okay, but generally the high quality premium products we use laminates. Okay, advantage is that high protection, premium feel. Challenge, of course, this is not a single material. This is six layered material having at least two to three components: plastic, paper, aluminum, other things. So the recycling is a problem. So of course, it will add cost to your final products. So that's one of the greater bottleneck in this way. So we choose based on the product price. Sometimes the packaging is so premium that it will increase the price of the final product that you don't want your consumer will deny to buy your product. So that's why we choose based on the packaging material, your product that matches the packaging material. So you choose based on the desired criteria. Very interesting question comes. Okay, we had talked about plastic, packaging, paper, laminates. What is the general criteria to select any packaging material? So you have to ask certain question as a manufacturer or as a consumer, for example. But usually we look into manufacturer perspective, producer perspective. So first question: is the product sensitive to moisture? Then you can say, yes, if it is a sensitive to moisture, what kind is your product? Probably gummies, toffees, like sticky. Then you need to go for this kind of packaging because you need to have flexibility at the same time you want value. But if it is not, then you go for moderate to high barrier property, but better rigidity because of the PET. So if it is not, then you ask for the next question. Is aroma retention is important in your product, for example? Yes. If you think it is yes, then you have to go for foil or laminates that I just discussed in the previous slide. And if you feel it's not very important, aroma can be retained. For example, in chewing gum, sometimes we just go for ordinary kind of paper packaging. Sometimes we use many plastic wraps. Another question is the product is sensitive to heat. Okay, previously we see the product is sensitive to moisture and aroma is a problem. Then you see that the product is sensitive to heat. So go for what kind of choice you should take. Okay, if it's no, then go for PE or any other kind. Another criteria is the product rigid or needs structural support in case of chips, in case of crackers. We see that if the package is requiring, if the material of the food product is requiring some support, we go for what kind of package. If no, then you go for any other kind of laminate or flexible kind of packaging. Then sustainability is, of course, we are living in the world where sustainability matters a lot. As I mentioned about plastic, okay? So we want to make alternative sources. That's why my research is more towards finding biodegradable option for packaging. Okay, so similar to Prof. Nurul also, that some of his study also about finding biopolymers for packaging, biopolymers for food. So sustainable production, as we have aware of sustainable development goal by United Nations as well. We have 17, I think, SDGs. So sustainability is all about our life. That and if we see that if a product we want to have recyclable, sustainable, then go for something mono PP. Mono means only single material, polypropylene or polyethylene. Don't blend to make it a laminate because as we have just seen that laminates are hard to recycle. So go for the mono material. So similarly, if it's not, go for the laminates or multi-material. Okay, now it comes to the packaging formats and what kind of technologies available. So based on all, if we can scan back and look back the categories, then the packaging requirement, then packaging materials, then now we coming all that packaging material giving us what kind of shape to our final product to market or to present or for the consumers to appeal to buy your product. So what kind of formats available? For example, flexible packaging, like give an example as wrappers and pouches. It is common for what kind of material? For candies, chips, and snack bars. Types, as I said, flow wraps, like your material is on the stage of the packaging machine, and during that flow, it get wrapped. Okay. Then pillow pouches, like you have fill, and you got a pillow. Okay, that's why we got pillow pouches. Means they kind of fluffy. As a given example is lace. You might see bigger serving size. You can see the pillow. Stand up pouches. Some pouches can stand up pouches. Some have flat bottom pouches, matte gloss pouches. So different kind of pouches, but the objective is to tell you that stand up means they can stand on their own. Comparative to lace bag, it cannot stand its own. Okay, it will fall down like a pillow. Advantage again, lightweight, cost effective, customizable. Because if you see most of the material here is from plastic waste. Okay, so that's why it is lightweight. Second format is coming rigid packaging like boxes, tubes, and trays for premium kind of products, cookies, and gift pack. Folded cartons. First example on the right. Plastic tube tubs. Okay, so this could be your different tub for ice cream, for multiple candies inside. Molded trays. So these are the molded trays, and we will go to the technology that produce this molded trays. It's called thermoforming, thermoblistering. So that technique gives us molded trays. As you can see that you can have multiple compartment, multiple blisters to have your product inside. So advantage in this case is that it's quite cushioning because you see all that product giving a kind of shape, external shape to your product inside. So it will give you cushioning effect, means support of your product to avoid it crashing. Then premium appearance sometimes, stickability. You can put multiple pack one on each other. That's why we call stickability. So here are comes to the packaging processes. Like we have packaging materials, we have packaging products. Now packaging processes. As I mentioned, we have seen the name flow wrapping from few of our slides. So this comes to flow wrapping itself, how it works, how it looks like. Flow wrapping, a high-speed packaging method used to wrap individual confectionery items. It could be chocolate bar or any of your candy that individually wrap, okay, are sealed from two end wrap, okay. So in this picture, if you can see, The main process comprise of three, four points like feeding. You have your film roll that as a packaging material, usually a plastic film or a metallized film. Okay, so it's coming from different shapes, and once it comes to the hair, it start forming a box. And from here, from this side, you can see your feed is coming. The feed means your product, your bar, your chocolate bar, your candy, whatever is coming from this side. So it could be horizontally and it could be vertically too, but usually the horizontal platforms are more frequent in this kind of flow wrapping. So your product is coming and your packaging material is coming. So here it is making and sealing. So this is already inside the tube of your packaging material because here they form in the box. So they are already in the box. And here is the end sealer. So you can see now the product is sealed end to end from here to here, here and here. So you can see that wrapping process in a flow. That's why it's called flow wrapping. While your product is in a flow, they keep wrapping. So main stages comes firstly you have your feed, then you are wrapping that material in a continuous roll or film or a box material, whatever you are selecting. Usually, as I mentioned, plastic films. Then you are sealing. So this is the point where you're sealing, and sealing could be longitudinally at the bottom only sometime if you are going up to down, for example, and it could be two end seal. Okay, you want to close both ends because it's already the other two ends are closed by the tube of the plastic. The other two end you want to close by this sealer. Then after you seal it, you cut because you don't want your product finish is not nice. For example, your product pack having only volume, for example, 100 ml, and you give that big plastic around that. So you think it's presentable? Of course not. So you will be cutting into the desired package. So the use for this technology is for the bars, candies, gums. Okay, as we mentioned earlier multiple times that what is suitable for this kind of technology. Second process is form, fill, and seal. Okay, so in the first we see that product is coming and we are just filling and sealing. But in this way, from the sheet of the plastic, for example, we are making it into a shape, into a tube first. Our packaging material is converting from a flatter material to into a film that is sealed, and then your food, okay, or your candies or your chocolate cubes are filled in that package, then the top is sealed. So that's the difference from the previous technology to this technology. You can see in the picture as well, but let's read what it is all about. It's efficiently creating filling and sealing at the same time of single in a single continuous operation. Okay, it have three stages as this name shows: form, fill, and seal. Form mean it will roll the film into its proper shape of pouch or bag. Then the pouch or bag will be filled. Then thirdly, it will be sealed. Okay, based on the design of the machinery, you can choose to seal the bottom or the top at one time because you already folded. Sorry, you already use your material that is unwound and forming a film. Then the sides are already sealed. The remaining is so you already sealed three ends, and probably once you come here, you cut into small pouches and then you fill it. So it might have vertical, okay, like you have seen this example, vertical form fill and sealing for chips, popcorn, nuts. For horizontal, like candy bars, cookies, it can go for horizontal too. Okay, so in this case, different food or different confectionaries you can select. Then packaging process number three, as I mentioned, if you remember thermoforming, I mentioned this term earlier in my presentation where we are getting this kind of thermoform containers from plastics, okay, or from certain laminates also. Thermo means with the heat, forming means to form. So it shows the technology works under heat and up to a critical Like melting temperature of the plastic, you might have seen polyethylene have lower melting temperature than polypropylene, then PET. So based on your packaging material that you select, like here we have seen PET, polystyrene, polypropylene. So based on that melting temperature of that plastic polymer, you select that you want to heat it. Okay, usually if you have seen originally this plastic that you see in your hand or in your package of, for example, of your candy is not originally it's not in this form. Okay, so mm, usually it comes into the polymer is sold in the form of grains sometimes or in the form of powders. If you look into commercial manufacturers of polyethylene, they are selling their products into pellets or powders or grains. Then the processor or the manufacturer who is making the plastic bags, okay, by using they melt that. So there is a process we call it what we call it, we then add some plasticizers, okay, other additives, some flavorant sometime, okay. We give want to give our final plastic package certain aroma also, and we want that particular shape. So to bring that original powdered polymer into any kind of plastic, you need a process of plasticization, and for that you need different kind of plasticizer could be any additive that lowering or reducing the melting point of your plastic, okay, that help to thermoform, okay, that help to form the plastic in its original shape in the sheet, okay, plain sheet before making into compartments, for example, okay. So that is the process of making normal plastic. Hopefully I think Prof Nurul is expert and familiar with that kind of process, and hopefully I guess you are taking some kind of courses where you see that how this plastic is formed. So my topic is a bit irrelevant, so I'm just focusing on thermoforming right now. Then you want to shape the mold into different form, specific form commonly used for packaging trays, containers, and blister packs. So the process involved in this is heating, forming, cooling, and then trimming. So if you can see here at the bottom, you heat that polymer sheet or tray, whatever. It is not having the compartments like this before. Okay, so this sheet is coming, the forming film. You can see forming film. So this plastic film or a composite film is coming, and then you heat it to certain temperature based on the polymer that you are using: polystyrene, polyethylene, polypropylene. So this machine is defined based on your program. Then you fill your product in that. Then you provide sealing at the top. So you get that kind of package at the end. Okay, so the process include heating. A plastic sheet usually, any of the polymer is heated to soft moldable temperature. Okay, and this involves a little bit of physics as well. When you see that glass transition temperature of different polymers, so I don't know, it may be you more confusing to talk about right now. So better to stay with our current topic. But different polymers have different glass transition temperature before being melt or molded to a different shape. Okay, you can check, you can Google to find more information. Then forming, once your sheet is moldable or heated in the form to be molded, then it's stretched or pressed over a mold. So you can see this is forming. So a mold punches inside. Based on the shape of the die or the mold, you can get any kind of shape. You want multiple compartment at one time, or you want one compartment at one time, depends upon your package. Okay, so it could be for primary packaging and it could be for secondary packaging. Okay, so the sheet is stretched and pressed over a mold using vacuum or pressure, then by mechanical force because it's already molded, soft enough. Okay, then go for the cooling. So once you get the desired shape, you come to the cooling. Okay, so after thermoforming, it gets cooled. Actually, here is missing, I think. So it get cooled to retain its shape. Okay, once you melt, then you bring it to lower temperature again to stabilize that plastic material. And finally, you cut it to make, you trim it to the excess material to get only the nice shape of your final holder or container that you develop, the tray that you develop already. So it could be used for chocolate tray or it could be used for candy blister. So it could have multiple items and multiple uses. So this is the third technology. Uh, First was what form flow wrap. Second was form fill and seal. Third is thermoforming. Okay. So now the technologies that could be used for packaging material. Okay, one is modified atmospheric packaging. You already know that modified atmospheric packaging, once the name is showing, it's not ordinary packaging material, it's a modified atmospheric packaging material. What the modified atmospheric packaging provides us and how it is formed. So inside of food packaging, we have different categories, okay, which adjust the atmosphere of the food. Okay, for example, here in kind of potato chips, we see that nitrogen gas is flushed. Okay, so instead of air, we are using nitrogen gas. So why we are using nitrogen gas? Because we know that we don't want our product to be rancid. So if it is having oxygen or air, normal air and humid air, it will spoil our product because we have some kind of oil, okay, used for preparation of potato chips. So in the normal air, you can see the shelf life will be shorter. Then extended shelf life of the product, the modified atmosphere packaging. So it could be extended, it could be extending, it will be extending the product shelf life, and it is a replacement of normal air with other gases. This is usually the nitrogen and carbon dioxide and any other blend of them, depends on your product inside the package. And the composition of the gases could be different, and usually we use inert gases that are non-reactive to the food components. And here are different kind of benefits it can give to your product. Another is vacuum packaging. When you see the vacuum, we say that we remove the air. Okay, so for example, in this kind of nuts, peanut guard, whatever. So it's a vacuum packed material. So we have removed oxygen. Of course, where is oxygen? And if we have removed the oxygen, there will be no oxidation, no spoilage, no rancidity. Okay, no off flavor development, probably for a given particular period of time of shelf life of your product. It will preserve flavor aroma better, it will improve your shelf life better. Product presentation sometimes improves also as well. But this is not suitable for fragile item. Okay, for example, chips, snack, crackers. So again, the materials used. Okay, so another interesting technology that is not fully adopted by industries yet, but to just give you an idea that what the packaging that we have, active packaging. So this is not a normal packaging just providing a barrier, a cushioning effect. This is more than that. Why it is more than that? Because it has some active additives added inside the package or inside your packaging material itself. Okay, so examples could be oxygen scavenger. For example, you want to remove oxygen from your pack. Okay, so it can eliminate oxygen, and once it eliminates oxygen, definitely no rancid reaction, no spoilage of food will happen. So the agents that are used are some example here: ascorbic acid and enzymes, also glucose oxidase that can scavenge. Scavenge means remove oxygen. Some of your packaging you might have seen they have kind of a little bit of silica gel in the white pouch beside your food sometime. And they said, don't eat this. So that is moisture absorbents, okay, in your packaging material. That is usually silica gel, it could be calcium oxide. If you look on, see this is the active in the picture, active sachet. I mean that is kind of oxygen scavenger, it could be the moisture absorbent. So once your food is there, so it protects, okay? That active sachet will protect your food by absorbing oxygen. And if you just make that compound or additive inside of your packaging material, not in form of sachet, you still have kind of protection effect by that additive. So previously we have seen that a lot of additives are added into the food, like for example sodium benzoate or any other ascorbic acid or any other acids that are just used in the food directly. So in active packaging, in your confectionery or in your snack, we design or it's a means a technology where we just add active additive into your packaging material itself. We're not adding directly into the food. Okay, so it protects your food and preserve your food for a longer period of time. So that's called active. It's not only passive packaging, it's active packaging. Then intelligent packaging is more than interactive packaging. Why? Because it will communicate, it will monitor, and it will let you know as a consumer and as a manufacturer that what have happened with your product. And in this case, it monitors, sends, and communicates. Okay, it could be time temperature indicator, like here you can see at what particular temperature, like for example 8 degrees, and how many days the product tag can tell you. Like for example, if you use that tag for, and tag is designed for that particular material actually. So each tag could be used for a particular packaging material. So these tags have, they can tell you the say brief, moderate, and the prolonged. So you can see that is it stored for a longer period of time, and what was the temperature. If the temperature exposure was above that, below that, so the color will change here. Sorry. Similarly, you can see the freshness of your product is still there or not. You can see that some tags are in this form. So once they interact with the packaged food inside, then your packaging material can tell you, okay, it is still fresh. So color is keep changing, and fading. Maybe for the fifth day, you already see your package is not fresh anymore. Don't consume it. It's not good to consume. Okay. So the day in this way you can check your package can tell you your food inside is not okay to eat anymore. Okay, better not to eat, for example. And there is another technology that used in intelligent packaging is radio frequency identification. So this kind of tags are also available in different other purposes, but here we are using it for food packaging, RFID security for your food pack inside. So it contains microchips and an antenna that stores the product ID, the batch number, the expiry date, and everything, and transmit to the manufacturer, and then they can use data logger to see that the product is having any kind of issue or not, anyone is tampering the product. So the signal you can get through RFID tags. Of course, these advanced technologies are not fully accomplished, fully adopted in industry right now, but certain premium products like this example for a cup of, I think, kind of coffee or some other items could be used that are premium products, and that ensures your product is safe and it reduces the waste because you can see the expiry date well before time and you can manage it and you can recycle it whatever, so it will reduce the waste and it enhance consumer trust because once they know your product is so ahead of other manufacturers and you can provide them all that advanced technology, intelligent monitoring and communication information. So that also support logistics and distribution. It will easy. But of course, these technologies still yet to realize. If not mistaken, I'd have no certain example here to give you any commercial product right now. So this was the intelligent packaging. So this is just a comparison of active and intelligent packaging. So active is that, as I mentioned, that could be oxygen scavenger, it could be any microbial agents, then scavenge moisture or oxygen. Okay, then for the intelligent packaging, we want that package will communicate at the same time it is providing any kind of reference that your package, your food is fresh. You see, green, yellow, and the red. So here you can see that freshness is there. Then your freshness reduce already. And then finally, your product is not fresh anymore, and you cannot guarantee. So these kind of tags are there. So these are called colorimetric sensors. Like for example, I am also doing some kind of research on that using some plant anthocyanins. Anthocyanins are the plant pigments in different flowers and different leaves of different plants available in your place as well. You can see that they change the color with a particular change of condition of, for example, pH change. If microbial growth is there, pH will be changed, and the color of that anthocyanin tag will be changed. Similarly, if you got a lot of carbon dioxide production, of course, it will change the pH of your food inside, and then your tag that is sensing, so it will change the color. Okay, a lot of research have been going on this way, but I am unable to find any industrial application. So probably you can search further for that. So we have talked about packaging material, we have talked about packaging machines, their technology, how to form, fill, seal, thermoforming. Now the most important part that you got your package ready for different confectionery, different snacks, different packaging material, different forms, different shapes. Now you want to see that okay, your package can sustain certain distribution challenges, mechanical challenges, its barrier is okay, or it can protect your product or not for your given period of time or for the shelf life of the product. Okay, so we have some tests that we need to perform on the packaging material, or you can say your ready package, for example. This is a mix of both. Okay, for example, you can test your moisture barrier of your packaging material. For example, you have plastic, you have paper, you have laminates, and you can test the barrier properties against what? Water vapor. Is it barrier, is providing barrier against that or not? Is it providing barrier against oxygen or not? I mean air or not? Okay, so this will come. The test name is oxygen transmission rate. Okay, so you want to see that. So based on that, you assess if your packaging material giving you particular barrier against moisture, oxygen, light. Okay, so these are the American system of testing materials. So and ISO as well. Okay, standard organization providing their particular reference SOPs, standard operating procedures that you can adopt to check any of the relevant packaging material, PAT, PP, foils, laminates, whatever multi-layer films, are they stable? Are they providing ample barrier? So you can categorize. Okay, for example, if I give you example, any laminate, aluminum foil is a better moisture resistant compared to polyethylene. Okay, okay. Similarly, polyethylene is a better moisture resistant compared to paper. So we have studied some packaging material. So based on the packaging material, you can adopt the test, and based on your expected purpose of the test. So you can see the barrier properties are matching your shelf life of the product that you want to achieve. Okay. Secondly, it comes to the mechanical, strength it is providing to your material. As we have seen that if you are packing your chips, potato chips or snacks inside a packaging material that is what they call flexible, but it have no cushioning, or for example, to improve that uh, chips to avoid crushing, we are using some tubes, okay, or laminates, a blend of that. So in case of Pringles, for example, I don't know many other example. So you can see that container, Mr. Potato brand locally available. I'm not sure it's available in Indonesia or not. So they're using some tubes, okay, that is providing mechanical properties better to compared to the flexible pack. Okay. So in mechanical property, what we usually test, we see the tensile strength. Tensile strength means if we on uniaxially, if we want to stretch it, how far it can bear that strain, okay? I mean stress. Okay, so that force that we are putting on the packaging material. Is it tearing, it is stretching or not? Okay. So we see that if it is flexible or not, it's very rigid or not flex. Okay. So we, based on that particular standard reference, we can see our packaging material could be tested for their elongation, for their tensile strength. Okay. Then burst strength. Of course, once you have made some packaging material and you want to see that a package, for example, imagine potato chips again, and you want to see that how much pressure, how much strength it can give before it bursts up. Okay, sometimes if we are a bit childish and want to be funny, we press our package to make it sound a boom. So we burst. Okay, so this is a burst strength testing. It's also scientifically proven method, but our method is not scientific enough. So it could be tested for different kind of packaging material. Drop test to see that if a package in the paperboard or whatever the carton, if it goes fell down, it goes to the ground from particular height. Okay, based on that particular standard method, you can see that carton, pouches, or trays can hold the food inside safe. Okay, so this is called drop test. Then you also do compression test to evaluate that if the stacking ability and durability is there for your corrugated board or rigid boxes. Some other tests that available to check the integrity and the suitability is the seal integrity. Like you have defined, we already you already use firm fill seal, so you already sealed from ends, both ends or four ends, whatever, based on your package. So if you have sealed already, you want to see the strength. Is it leaking or not? So that you check the durability of your package. Okay, then you see that if any leakage is there. So if there is a leakage, mean the sealing power of that polymer that adhesives are not fully integrated, fully the laminates, whatever your packaging material is not fully sticking, okay, at the edges. So if there is a leak, mean there is a chances that microbial contamination is a chance that oxygen, light, and all other extrinsic factor that can reduce the shelf life of your products. So we want to see that it's leak or not. So leak detection. Sorry, I could not give you the details of each method that how they work because this is not a packaging class typically, and I think based on the time given, it will be a lot of stuff to digest at one time. So food safety, for the food safety, we see overall migration. For example, there is no harmful leaching into food. That is, I think, most important factor that we might have heard in our life, that every day we see that if you see that some plastic packaging, they said it's a BPA free. Okay, so there is a particular compound bisphenol A, so that is a kind of carcinogenic and have mutagenic effect. So we see that overall migration of any additive, the plasticizers that we are using into plastic packaging, and food is coming in contact with that. How much migration means any of your plastic additives that have been used in the packaging is transferring to your food. So we want to see overall migration. Then for particular ingredients, okay, for example, you see melamine is specific migration. So we have other additives that we have determined that only particular percentage of uh, compound in sometime micrograms, okay, or nanograms should not exceed that particular amount, and it should not migrate more than that to your food. So we check overall migration of the plastic additives and sometimes specific migration also. Okay, that overall migration is valid for all food contact material because in your plastics you have additive, and then in your paper you have printing inks. So sometimes that inks and dyes that are not food grade, that having heavy metals. So the probability of migration of that packaging ink to your food is very normal and very obvious. So for that we have overall migration and specific migration. Sorry. Then thermal testing. You want to see that, sorry, you want to see that finally The sealed material, the packaged material, is it heat stable? For example, your ambient condition at your room, at your home, or at the grocery store is around 23 degrees Celsius, for example, 25 degrees Celsius, for example. And then if the temperature goes up, for example, like if you ship your product overseas and it goes to, for example, India, and the temperature over there, for example, reaches to 40, for example, do your product have that heat sealability? Okay, that it can stand that a little bit high temperature and can have its own strength as is originally packed. Then you see the heat sealability. Okay, so it can, I mean, it can hold that heat shock. Okay, and then at the same time, it's not only heat shock. You can see the shrinkage and dimensional stability. For example, if you have prepared and you can stack it or not. If you package potato chips as snack, is it shrinking with the time because of the transfer of the gases from the packaging to outside environment, or whatever the exchange of gases happening through your packaging material? Is it shrinking with the time, or is it exploding with the time, for example? So all that thing we have to see that can maintain its dimension for particular time, typically the shelf life of your product. Okay, so it can give you ample stability and heat sealability to keep your product intact until the time you use it, or until the time it is consumed. So for that we have another test. Okay, so it is valid for what kind of material? Shrink wraps. Okay, then we see the flow wraps. So either they already shrink and change the dimension. And then chemical resistance. So sometime, as we had again as an example, that you have potato chips and it have oil inside, some flavorants inside, some other kind of, and pH of the food may be little bit acidic. Okay, depend upon the composition, because you have fatty acids, so probably the pH will be lower than 7. So it should be around 4, 5, something like that. So is the packaging material is chemical resistant? So the chemical could be your oils that you're using for frying, or overall pH of your food item. So we see that what kind of a reaction it is making. Okay, so we see that coated, paperboard, PET, all that packaging material could be tested through this standard method. So here are some key players that are innovating, and I mean, they are leading the packaging of snacks and confectionery. Um, some names that you can see is Nestle in form of Kit Kat, Smarties, Mondelez, Mars, PepsiCo. These are the current industrial players of global village that they are innovating and following the sustainability goals, and they are providing some innovations. So let's see what kind of innovations they have. The Nestle, they have sustainability goal to reduce virgin plastic. I mean the plastic in its original form, not the recycled plastic. They want to reduce the original plastic usage by one third. Mean they want to cut their plastic usage, for example, 33% compared to 100% by 2025. I'm not sure, I don't know the current stats of this, even they have achieved that goal or not. But their initiative in that of reducing plastics are what? They have used paper-based wraps for Kit Kat, lemon chocolates, or things like that. And they have developed some R&D sections and packaging institutes as well to improve their efficiency. Model is 100% recycled packaging by 2025, means they will not be using virgin plastic at all. They claim to use, they're willing to use, and they're trying to come to that 100% recycle. Because if we look on sustainability, whatever the food we're consuming, every activity that we do as a food producer, a consumer, we have to be looking into sustainability. So here, that's why the efforts are going on. Sorry. So they recycle flow wraps for Cadbury chocolate and some other Oreo biscuits as well. Mars also using 100% reusable, recyclable, and compostable packaging. So you see, reusable means if you can reuse, then recycle means you mold, you melt, and you make another product. Compost means that you can check the life cycle assessment and you see that if can be this could be converted into compost or not, if can be degraded or not. So they say they're claiming that they can make products 100% recyclable, I mean their packaging material 100% reusable, 100% recyclable or compostable packaging by 2025. So in these terms they're using resealable pouches for M&M, bunties, chocolate bunties they're using M&M. Flexible plastic recycling is another ambition for Mars. Okay, and then PepsiCo is reducing packaging waste and supports circular economy. So they want to, when you talk about sustainability, it comes to circular economy as well. Circular economy means you are generating something, and that byproduct or the end product is a raw material or is a feed for next cycle. Okay, that's why it works in a circular form. That's why circular economy. So this could be more towards business terms and sustainability terms. Better you read about it by yourself as well if you're interested. Compostable chips bags that are used mono materials because if you want to reduce packaging waste and make it recyclable, as we mentioned earlier, mono PP. Okay, we are not using laminates much, but we are using single material, either PP alone, PE alone, PET alone, whatever. So using mono material, a single material at one packaging products. So overall, if we can see that Nestle is innovating through paper-based innovation, Mondelez is focusing on portion control and recyclability. Mars also in emphasizing on freshness and resealability, and PepsiCo is investing in single material that is recyclable and compostable. So they are having their campaigns regarding that. So this is, I think, if not mistaken, the second last or last slides that is talking about innovation and in sustainable packaging. So whenever we are talking about food production, consumption, and typically to preserve it, then we want sustainable kind of approach. So the innovations that are coming into market are firstly, okay, that is slogan. You can reduce, and then you can recycle wherever possible. And you know that every packaging material, especially plastics, that you can see at the bottom of that bottle, there is written that particular number is given 45312. So that is telling that this is the material category of PP, polyethylene, that whatever the category, and that is recyclable symbol. This symbol you can see in your drinking water bottle as well below that. Okay, so innovation in sustainability is that first thing, edible packaging. Like for example, you have rice paper wraps instead of just cellulose based or plastic based wraps for chocolate bars or for your candies, for example. Like you need not to remove anything and open it. You just take any product from the, I mean, secondary package maybe, and you directly consume it because you already have edible packaging. Means that package with the food itself, with the confectionery, with the snacks, you can eat directly. This is one of the example. Then water soluble films. For example, now some polymers that are produced from bacteria, like for example, polylactic acid, another um, or other, like for example, starches, their films, protein films, for example, gelatin. So that I'm working right on it. So these are water soluble films sometime. So we are not worried that this polymer will not be degradable and not compostable, but it is soluble, so it will easily degrade it. So once it's dissolved in water and in ocean or any ecosystem, of course it will be easily consumed and it is not harmful because it's just from the natural resources, typically from plants and animal resources. Then again, it comes to plant-based inks and adhesives. For example, as I mentioned that in intelligent packaging, I said that we are making colorimetric sensors to develop intelligent packaging. So that is based on inks, particular inks. And to seal your products, you need some adhesives. Okay. For example, some fruits having some gums that are giving sticky properties. Okay, it's easy for you to make natural adhesives instead of any synthetic adhesives. Of course, synthetic adhesives are sometimes cheaper and durable, and but we are talking about sustainable packaging solution. So when that plant-based inks are available, as I mentioned, that some plants have flowers have anthocyanins, okay, coloring compound that change they can give us color. For example, if you can see like not roses, but what example like all the colorful plants, if you can see their leaves sometimes have that not the green one, other than the green, usually the purplish, the reddish, all have anthocyanins that could be used in making inks. Okay, colorful inks and adhesives based on the plant material that you can use. So some adhesives are available in different plants. Okay, because even you get rubber, okay, from rubber tree. So it means that plants can give you some adhesives, okay, similar biopolymers. And brand initiatives in that, as we mentioned in the previous slides, Nestle is going for paper-based wraps, PepsiCo is going for compostable chips bags. So that is the another innovations going through commercialized brands. And consumer engagement is going on that you can see through QR codes that what is the recycling way that if you have seen on your bus terminals or train stations or subways, you might have seen there are different containers, one, two, three, plastic, that, aluminum, that, and then ordinary, just general waste. So based on the QR code, you can get the information sometime about your package that you are using for your food. Okay, in which category it can go, the wrapper can go, or the package can go, so that they can recycle easily. And sometimes you might have seen they're giving incentives for eco-friendly choices. For example, in certain countries, you might have known this example, like bring us 10 bottles, empty bottles of that particular food item, that boxes. Bring 10 boxes, get one ready made food. Okay. So this kind of incentives are given to promote eco-friendly practices among general public. Okay, so we are summarizing our lecture, our session in different aspects. Firstly, we talk about that packaging is essential for basic functions, protection, preservation, branding. Then material we selected and different candies and for different confectionaries and snacks, we have talked about that. Then the material selection depend upon your product type, the shelf life that you expect. It will have 2 year, 1 year, 6 month, 3 month, 2 month, whatever. Then again, the machinery, the technology. I mean, form, fill, seal, thermoforming, wrap flow. Okay, so you will see that technology streamlines with your product and the product type that can define any particular packaging operations. And beyond that, we have discussed the most important section was the testing. If you have any package ready or the packaging material with you and you want to use it for your packaging of your food stuff, for confectionery, for snacks, whatever chocolate, do you see that your package have ample mechanical barrier properties? Inertness is safer for the consumer, safer to be as a food contact material. And sometimes you want to see the transparency. If it is suits, you want to do branding and it is providing you some transparent window, whatever the objective. So you can see based on that, it fulfill the particular standard operating testings. Okay. Then sustainability that we have talked about in the last slide, that all the innovations and all the packaging formats and material is driven by sustainability now. That's why all the manufacturers, all the leading packaging suppliers, product suppliers in terms of Nestle, PepsiCo, they are providing, they are driving sustainability as their main objective. Okay, so probably these are certain references in case you want to dig more into what I have discussed here. Some standard methods and some books that have been consulted to prepare these lecture slides. And thank you very much. If you have any question, please go ahead. Thank you very much, Dr. Ernie and Prof. Nurul, and to all students in the lecture. So please go for any question if you have.
Okay. Very, very, very comprehensive material. Thank you so much, Dr. Kaiser. It was so nice teaching. Okay, student, it's time for you to ask question. Should you any question, please. While we have like expert here in packaging thing, you might ask several questions. Okay, this time the time is yours, student, please. Student. You may raise your hand to asking the question, or if you shy to directly talk. Oh, okay, answering already. Like raise hand, please. Directly answering.
Okay, ma'am. Thanks for the opportunity. My name is Azarin, and I want to ask about the differences between the active packaging and intelligent packaging. Can you re-explain about that? Because I don't get the differences between the active and the intelligent packaging. Because I think that the active and intelligent packaging uses the indicators that can be do both as the um, respond to environment and communicate it to the consumers. That's all from me.
Uh,
Thank you.
Thank you, Azarine, for your question. Actually, when we look into active packaging and intelligent packaging, active packaging is, you can say that intelligent packaging is also sometimes an active packaging. But intelligent packaging, if you have seen the slide, I just mentioned that active packaging is providing you real time in terms of preservation kind of effect. It might not communicate much with the consumer. Even not it's not interacting with the consumer to tell that if the food is safe to consume or not. But in case of intelligent packaging, the category that I touch, I said that RFID and colorimetric sensor, freshness indicator, time temperature indicator, it shows that the consumer can see the package and can decide, oh, the food is fresh, not fresh, or not consumable anymore. So the difference in active to the intelligent is that intelligent is communicating and giving you the information to the consumer that don't take or take fresh or not fresh. But the active packaging is just for the sake of preservation kind of thing that it can stand the desired shelf life. So that guarantee that your product is stable, but it not giving any indicator to the consumer that okay you can take or not unless the consumer open that product and do kind of sensory kind of evaluation and think to consume or not based on the flavor, the aroma, or the appearance of the product. Hope I justify the answer of your question.
Yes, sir. I get it. Thank you very much for the explanation.
You're welcome.
Okay, next question, please. Again, if you wanna ask, you can like raise your hand, or if you shy enough to talk directly, you can also like write down your question in chat room, please. Any other question? Student. Okay, Ines, raise hand, please directly. Ines, you can ask your question. Ines, you still like mute. Turn on your.
Okay. I'm sorry. Well, my question is that for intelligent packaging, it is intended to show freshness and quality of the products. For example, the packaging could indicate color changes or some other indicators. However, as we know, confectionery and snack products are often exported. So, how can intelligent packaging maintain their accuracy when products are exposed to like varying temperature, handling condition, and other factors throughout international transportation? So that is my question.
Oh, thank you very much for your question, Miss Legania. Uh, as you already explained that you just given the example that it communicates, okay, as a perspective of manufacturing, because you see that if the traceability is not there, if the traceability is not there, you cannot recall your product. Okay. So as a manufacturer perspective, if I want to distribute or by my means want to export my product and I see that RFID tag, for example, maybe the color changes are also effective in this way. I mean, colorimetric sensor are also effective in this way that you can define that your product is tempered. I mean, temperature fluctuation already been happened once it was transporting. So at the point of delivery, at the point of retail, you might not be selling that product anymore if it has already been malpracticed or exposed to unconditional, I mean, not suitable, I mean, the storage condition or transportation condition, for example. So in any case, even if it's a colorimetric sensor or RFID technology, you have traceability as an option and the visual change of the tag that can define as a retailer that you cannot sell it anymore to the market. So it will not be able to go to the shelf and consumer may not be able to take that product. So I hope that in this way we are very, very clear that product should be recalled back to the industry. Hope I get your point, and I think I answered probably.
Thank you for the answer, but what I'm asking is that how do the factory actually maintain their accuracy so that if it is exported, the color will not change?
Oh, that is, I'm not actually working in any industry practically, and I have no certain answer, but probably as a supplier, as a manufacturer, and as a distributor, you know your requirement. And if it is not reaching to that, of course, it is just based on your particular demand that your product can bear that particular distribution temperature, storage temperature. So I think there is only the traceability of your product that can help the industry to maintain that if it is not tempered, temperature tempered, or any other malpractices to your product have been done. Because sometimes to defame any company, they also do. Maybe I'm not. It's not a very good example, but maybe your transporting clients, they can do something wrong with your product and temper the product. So once it goes to the market, it will be getting blamed because people got sick or any kind of outbreak happened through your product. So definitely you will defame. So they are really, really making sure that everything is going well. That's why RFID tags and other advanced technology really giving nice traceability idea to protect the brand name of any company.
Okay, thank you for the information, sir.
Like,
Okay, guys, we still have like one more question, one or two more question. Anyone? Anyone? Any other question? Any other question?
so seems like e- either all the students grab every part of the slide or the content, or most of them didn't get anything. I'm worried.
I believe that they get many things because your teaching is very clear and then it's
I
like
think the question from Camila.
Camila has question right now.
Yeah, Camila.
Okay, Camila, you can directly ask the question.
Okay,
Yes, please.
thank you, ma'am, for the time. At first, I apologize in advance, Mr. because I cannot open my camera because I having some trouble. So, what my questions is, so first, I'm interested in chocolate and potato chip packaging. What the mentioned before. So, what do you think about the specific challenges in packaging chocolate and potato chips, especially when it comes to the fragile nature and temperature sensitivity of this product, like that. I think that's
Okay, thank you, Miss Camila, for your question. So, if you have checked my slide as well, the time I was expressing that what the choice of packaging material we can have. So, probably your question is about selection of the material. So, I already mentioned that if we have potato chips, like for example, Lay's as a brand, one of the examples. So, if we have pillow pack or cushioning effect that we want to not to make it, we make it to what we call crush resistance. Okay, so we probably go for selection of the material that can give a longer protection. So in this case, we can choose rigid material, but usually the packaging material that we're using for lace is just they have nitrogen gas filled inside, so that give it a cushioning effect, of course. So I think that the choice of material, the packaging of that particular chips are the chocolate. For the chips, I have mentioned you can go for any other stable material, rigid material. For example, if I give you example, as I have mentioned already, the Pringles that are coming into a stacked chips are stacked in that particular bottle. That is a composite bottle, laminated bottle, and have a lid on it. So you can consume one by one and based on your portion and desire and demand. So that goes for your chips related question. Like even you can use cushion, or if you feel like you need more further stability of your product, you go for the tubes. That is Pringles sometimes selling in the grocery store. For the chocolate, of course, as we mentioned that based on your cocoa composition, if it is dark chocolate, any other additives, raisins, nuts. So if you think that stability at the first place, of course, go for the rigid kind of packaging material, provide some cushioning, okay. But again, blending of your original chocolate with other kind of additives can help to make your product maybe heat resistant, relatively better than the dark chocolate itself. So if you think as a producer perspective, maybe the choice of packaging at the first place. But secondly, you can also go for a blend of means additives or raisins or nuts that you have seen in different slide and example. So that can provide you the, thermal resistant relatively to the pure content of chocolate, I think. So it's again, I cannot give you any specific that what kind of folded paperboard you can use for chocolate because that is secondary material, and again the stacking ability. So there are many other things come into mechanical strength of your package as we discuss in the testing section as well. So there is no, I think, hard and fast specification from my side at the moment. Sorry for that, but hopefully I'm trying to answer your question in the way that based on your product, you can choose any packaging material. But if you have seen the success of the packaging in our grocery stores that we are regularly consuming, I think in case of chips, I have given you very valid example that is we are really consuming daily basis. Hope I answered the question.
yes, of course, Mr. Thank you for the amazing answer.
Thank you, Ms. Camila.
Okay, students. You still have question? Anyone still have question? Anyone? Okay, I guess like yeah, because the time I believe that you still have some question, but we already 2 hours more than like 2 hours and 3 minutes, so I think it's too long already. So okay, for wrap up thing, please Pak Nurul for giving let's wrap up for this meeting. Thank you.
Okay, thank you, Dr. Annie. Thank you, Dr. Kaiser, for the great presentation. I think we and student learn a lot from your presentation. And also, I'm happy with the comment from the student, very active student. It's what we looking for from the student, active student. And I hope your presentation will enrich them with the packaging aspect for the confectionery and snack food. Thank you again, Dr. Kaisar, for your great presentation. I think it's all, Dr. Annie. Thank you for to moderate, to facilitate this guest lecture of Dr. Kaisar. Thank you, Dr. Annie. So,
Okay, thank you, Professor Nurul. Okay, student, it's time for like taking picture. So please show up your face, and then we take picture. And after that, 10. Okay, please open up your cam. Okay. So this is our student, Dr. Kaise. Is total about like 100 students join in this meeting today. So, okay, guys, be ready. We will take picture. Okay, I will count. 1, 2, 3, smile. Okay, let me do it again for next slide. Okay. 1, 2, 3, smile. Okay. Okay. 1, 2, 3, 4. Okay. Okay. I think that's all for today. Let me. Okay. Thank you so much again, Dr. Kaiser, for your nice teaching today. Share knowledge to us here, and then hope everything like hope this collaboration like useful both party, and then we can make collaboration in the future. Yeah, probably like in the future, one of my student, one of more my student will be your student as well. Yes. Okay. Again, thank you so much. So, for closing this nice weekend, we say Alhamdulillah for this teaching, and we close with Wassalamualaikum warahmatullahi wabarakatuh. Good morning.
okay, thank you.
Waalaikumsalam
Take
warahmatullahi
care.
wabarakatuh. Thank you, Prof. Nurul and Dr.
Okay.
Henry, and all the students who really make the morning very nice and enjoyable. Hope to see you again. Thank you very much. Salam alaikum.
Okay. Thank you. Take care. Take care all. Thank you.